Welcome everyone to What's New in Visual Studio 2022. My name is Cy Brand. I am the team's C++ developer advocate.
And I am Marian Luparu. I'm the group program manager for the C++ team. Thank you for tuning in today and giving us the opportunity to share with you why we're more excited than ever to recommend to you Visual Studio for all your C++ development needs. Before we jump into the content today, a quick reminder that we're around to answer any questions you may have, questions about the product, talk about any fun stuff that is happening at the conference, you name it. So reach out to us on the Discord channel, hashtag Visual Studio. And please don't forget to fill in our survey. This is the last day of the conference, and it would mean the world if you share with our team a little bit about yourself. It only takes 5 minutes, and it allows us to get to know all of you better. And that's whether you're a Microsoft customer or not, would like to hear from all of you. That's because we're hard at work year over year to empower you and your team to achieve more. That has been our mission for close to a decade now. And we work on that by contributing to the standard, not just the design, but also validating the standard through proof of concepts or full implementations like we did for coroutines, for example, in MSVC and Clang. We do that by conforming and innovating in the MSVC toolset, whether that's compiler or libraries, by addressing with vcpkg critical problems in the C++ community, which is acquisition. And lastly, by improving our flagship products, Visual Studio and Visual Studio Code, to support the best in C++ development. And we cannot do that without your input. So please go ahead and fill in that survey. We appreciate it. Now, our agenda today will focus on Visual Studio IDE, our compiler, and vcpkg. But if you do want to learn more about Visual Studio Code, I invite you to watch the recording of my session with CNM from yesterday, where we had lots of demos, some slides, covering the #1 most used code editor according to Stack Overflow. So now this session is about Visual Studio. So let's jump right into it with a piece of news. Now Visual Studio runs natively on ARM64 devices. If you have one of those, like a Surface Pro X with Windows 11 on it, you can install 17.3 release today. And it's not just the IDE that runs on ARM64, also the compiler now runs natively, while still allowing you to target, like x86, x64, ARM64 as you would expect. And to get you started, we've already validated more than 600 libraries in the vcpkg catalog that are available on ARM64. To learn more about this announcement, head over to the link below. And if you're on the lookout for an ARM64 device, Microsoft also announced earlier this year build an upcoming device codenamed Project Volterra, which is specifically targeted at developers. I don't have one, looking forward to one. And if you're interested, you should also stay tuned for an announcement on the public availability date for this device. All right, now, that was just to get us started. Our main agenda will cover conformance, performance, and features of importance. So let's start with C++ conformance. So for this one last year, when we were here at CppCon, we talked about how C++20 support in MSVC was feature complete. And while some features were still only available under the STD C++ latest switch, you could already try them all. If you did and shared your feedback with us, thank you. Where we are today with C++20 is that we completed all the last DRs from this year. And with that, all C++20 features are now available under the C++20 switch since 17.2 release Visual Studio 2022. And for those folks that got on our journey with us with Visual Studio 2019, we've also ported these changes to version 16.11. What this means is that you can adopt C++20 in your production code today And because the STD C++20 switch is binary compatible with older C++ standards and even older compiler versions, you can adopt C++20 at your own pace. In all of your code base, just parts of your code base, by including or not including your dependencies, it's your choice. If you're in experimenting mode and you want to try the latest features with STD C++ latest, you can also try many of the new C++23 features. For example, STD expected, deducing this, more ranges features that are coming with C++23. With STL being open source, many of these contributions are coming from amazing folks in the community. And I'll take this opportunity to say thank you to all of you showing your love for C++ in this way. There is more work on C++23, and the most notable item is the imminent release of the modularized version of STL. So please stay tuned for more announcements from us on this. Now, having a compiler know the latest standard is not enough. We need C++20 to reach the full end-to-end C++ development experience in order to become as ubiquitous as C++ itself. And so in addition to the work we've been doing in MSVC compiler and libraries, we've also been working super hard on integrating C++20 throughout all the layers of Visual Studio, from editing to building and finally to debugging. For example, only in the Visual Studio debugger, you'll find updated experiences for stepping, parallel stacks, visualizers, GMC, just my code, that basically make the debugging experience for coroutines feel like magic, hiding the underlying mechanisms and letting you focus your debugging specifically on the particular coroutine logic that you're implementing. In the editor, IntelliSense supports all the new language features, including the high demands of ranges, as well as providing assistance for concepts, for example, like you see in the screenshot there, where VS can infer the members of the template type in that screenshot based on its concept definition. The C++ module support in IntelliSense has greatly improved from last year as well, like night and day. And while we're working on known bug fixes in this space, please try it and let us know your experience, and please report any new bugs that you find. The way we think about it in Visual Studio, with the work we've been doing in the recent years and the work we're planning, is that Visual Studio is the right tool to help you be productive in the next decade of C++ development that we just entered now with C++20. With GCC and Clang continuing their progress on supporting C++20 and CMake making great strides to enabling C++20 modules as well, we think the pace of adoption for C++20 will only accelerate. And speaking of CMake, we're thrilled to have partnered with Kitware to work on exposing compiler capabilities directly to CMake to tighten the build system integration for C++ modules. In Visual Studio today, you can already use CMake to experiment with modules, and while it only currently supports the VS generators, as you've seen hopefully from Bill Hoffman's session on Monday, there's more coming soon. Check out the link below if you want to try this yourself. But if you want to see this in action now, let's jump straight into a demo. Sai, do you want to take it away?
Sure. So I'm going to switch over to Visual Studio now, and I'm going to show you a bunch of conformance and productivity advances we've made in the last year. So this is a simple text adventure game which I have made. Let me very quickly show you kind of the state of the game right now. So you can see it's not large, but it's not small either. We've got a bunch of files here, and this is just going to link the project and run it, and we should see popping up in just a second our little window. Here we go. I call it Jork because it's kind of similar to Zork. Press return to begin. So we get a little command line type thing, and we can type, look, you're in front of a huge hole in the ground with a rope dangling downwards. Marshmallow the cat sits next to it. And then we could go down, for instance, to lower ourselves down the rope and look again. And it's recognized that we are now in a slightly different place. So it says you're now dangling from the rappel rope and there's a bolt in front of you. This is pretty much all of the functionality in the game right now. There's not a whole lot to it, but it's enough to show a decent demo, I think. So let me give you a quick tour of the code base. What we have is, if we go to the entry point down here, you'll notice that we're using SDL main. That means we're using SDL2 as our provider for that window, for text input, all of the kind of multimedia stuff, images. All of that's handled by SDL, which means we have a dependency on the SDL2 library. Now our main game loop is over here in our game loop. Most of this is not super important, like this is when you're in the main menu, but the main loop of the game is in here in normal play. So we have some console, which we can scroll using the mouse wheel. If we do a backspace, then we tell the console to delete the last character. If we type some text, we tell the console it's got some new text it has to type. And then importantly, when we hit return, we're going to process some command. So we first tell the console to commit whatever command the user just typed, and we get it back as a string. If I hit Alt F1 here, you can see we now get this type inline, which is handy. We also get the parameter name inline as well, and then we can just hit Alt F1 to toggle that on and off. This is the new inline type hint feature. So once we have committed our command, then we handle the command using some logic, depending on what the command is, down or look or whatever. Then we display the response on the console. And most of the actual logic is in this handle command function here. So first we do some very simple parsing. This is not like the parser in Zork or something. It's basically just recognizing like down and north and south and such. But it can accept things like take with an object, or drop. You don't just take, you take wrench or take cat treats or whatever. And it will just return a string from all of these branches. So that is the kind of basics of this code base. And now I'm going to go through a bunch of interesting features in here and how Visual Studio can help. So one of the first things I mentioned there was that we're using SDL2 as that window provider. And how do we get this dependency? Well, for me, I'm using vcpkg right now, using vcpkg manifest. So there's a few different modes which vcpkg can operate in. vcpkg is a C and C++ package manager, which is developed by Microsoft in cooperation with the wider community. It's an open source project. We get tons of additions from all of you folks, which is wonderful. Now in manifest mode, you specify your dependencies declaratively just in a JSON file. So we have our package name, which is Jork, we have a version string, and then we say what our dependencies are. And vcpkg understands these strings. It has packages or ports for the core SDL2 library, for the image extension, and for the TTF font extension for SDL2. So if we were, for example, to delete the cache and reconfigure, then we will see some things happening. There we go, running vcpkg install. So it will do some hashing with the compiler to check what it needs to reinstall. And it's found that it needs to install all of these packages, not only the SDL2 and SDL2 image and TTF, but also their dependencies and their transitive dependencies. So a bunch of stuff gets installed here and actually gets restored from a cache because I had already installed these and I don't want to rebuild them all while I'm doing a live demo. It then helpfully tells you what your CMake commands are for finding the package and for linking against it. We get that for all of the 3 libraries which we had as our top level dependencies. And then it does just the general CMake step, and we're all done. Now, one important thing here is to get this all linked up and working, I don't just need the manifest file. I also need to tell CMake to use vcpkg. And the way I do that is with this CMake presets.json file. If you're familiar with CMake settings.json, this is like the successor to this, but it's standard. It's not just Visual Studio. It also works on Visual Studio Code. It also works in CMake itself on the command line, and a bunch of other tools across the industry can use CMake presets.json. So you can check this into CI, into your build, into your version control, and distribute it everywhere. So it should look fairly familiar. We've got a name for this configure preset, Windows base. This is where we're going to put all of our Windows configurations. And the important part here is the toolchain file. We are pointing it at our vcpkg.cmake toolchain file, and that's how vcpkg actually gets invoked after it finds our manifest file. Then from this Windows base, we can have an x64 debug configuration. We could have an address sanitizer configuration, one for release mode, one for 32-bit. And after we have all of these, they're selectable from this little drop down here, so we can easily switch between them all. Okay, so that's CMake. And you may have noticed, if you were paying attention right at the start, this is using modules. So like Marian mentioned, we do now have some initial support for modules, C++ 20 modules and CMake. Like Marian did mention, you do need to use the Visual Studio generator in here. You can't use Ninja or anything right now, but we are working on it. We'll continue to make advancements in that area. But for now, you can use the Visual Studio generator with CMake and modules, and it will all just work. So I could hit Control-Shift-B to build everything here. And note that we're not doing any magic. We're just using the regular CMake add executable command. We're giving it all of our C++ files, and we're also giving it all of our module interface files. Then, as this is building, you're seeing a sneak peek. I'm going to be talking about fuzzing later. This is all building. You'll see that there we go. It's now linking, and once it's finished linking, I can quickly talk through some of this output because some of it's kind of interesting. It's just building my fuzzer, and there we go. Okay, so at the top here, we can see the first thing it did was scan the sources for module dependencies. So we didn't have to manually specify the order to build these in. There are dependencies between these module interface units. So we do need to build all of these in a specific order, or at least in one of the valid orderings. So the first thing it does is scans all of our sources for module dependencies, and then it builds them in a valid order. And that's all just by supplying these to add executable, it works everything out. And once it's built all of the IXX files, builds all the CPP files, and then links. So that's all working, and it should give you the kind of experience that you're used to. We can come in here, we can control click, and it'll bring us directly to that module. We did have this last year, but now it's working with CMake, and it's a lot snappier than it was last year as well. So the regular kind of modules experience should all just light up for you. Now let's try and make some changes here. Let's say we want to add some support for building somewhere which exceptions don't work so well. Maybe we're building for the web with mscripton, or for a smaller chip, we want to run this on like a little handheld device where exceptions might be not quite so well supported. So we do currently have in our parser, many things could go wrong while parsing because we're just taking text from the user. So for example, if they type in too many words, like we say wait something wait cat, well, that doesn't make sense. That command doesn't take an object, so we throw an exception. But say we don't want to use exceptions, what could we do instead? Well, one thing would be to, instead of returning a command here, we'll return a std expected of a command and a string. Std expected is a C++23 feature, which is kind of like either a command or some std string representing the unexpected case. Something went wrong, there was an error. And you'll see we immediately got a little squiggle here because these declarations are not compatible anymore. Now, say we want to go to the declaration and fix this up ourselves. It used to be that if we control-clicked on here, it wouldn't take us to our declaration because these don't match anymore, right? They're not the same function. But now it's aware that there was some refactoring and it all just works. So we can now go here and fix up our type to make these the same and go back, and this will all work. So now we can make a few changes just to use std expected. So instead of throwing a runtime error, we're just going to return a std unexpected in these three cases. And then when we use this thing, instead of having a try catch block, we're gonna check if we got the unexpected case, then we're gonna return com.error. Why am I getting squiggles here? There we go. Just need to load up a bit. Hopefully when I rebuild, this will all be fine. So we're gonna return the .error there, and instead of com dot, we need to use com arrow in a few places. There, the squiggles went away. And we're not going to have a catch. Okay. Format that, and we should be all good to go. All right, so we've made some changes to refactor, and the navigation all still worked. But now let's say we've got an error. Maybe we want to also log some information so that we can debug what went wrong. Maybe this happens in a bunch of places. So this we would want to output the current stack trace where we were. We could, for example, say output std c error std stack trace current. And I think for this, I will just need to hash include these stream and the new C++23 stack trace library. So this will get the current stack trace at this location and print it out to standard error. There's a fair amount of API surface here. You can loop over your stack traces, like you can see there, there's stack trace entry. You can iterate over your stack frames, print them out, manipulate them, all the kind of stuff that you might imagine. Now, let's have a very brief aside into the actual implementation of std expected here. So if I go to parse command, I can actually control click on this and it will find the standard library header. I don't want to spend too much time in here because standard library implementations can be a bit scary, but let's have a quick look at like the value function. Oh, here we've got value and it's overloaded for if you call it on a const ref expected, a non-const ref expected, a const r value ref expected, and a non-const r value ref expected. And now these are kind of similar, like they're quite simple functions, not a whole lot going on here, but some of these do get quite complicated and we have a lot of them. So we have these 4 functions we're doing all the time with very, very similar code. The only difference here is we std move, and we all know how bad quadruplication can be for code. So what we could do in C++ 23, which there is now support for in MSVC, is get rid of all of these, get rid of this, and we can make this a template. So we'll introduce a template parameter called self, and then we're going to use the deducing this feature or explicit object parameters or whatever you want to call it. And we say that we have, instead of the object parameter, the thing we call this function on being implicit, it's now explicit in the parameter list because we prefix this parameter with the word this. And this now says, hey, this is our object parameter, and we're going to deduce the type of it, which means that it could be deduced to L value, a const L value, an R value, const R value, all of this stuff. And now we could just do stood forward of self dot value, and that will all just work. And now we have a single function which does the work of those 4 overloads. Deducing this also solves a bunch of other, I'm just going to delete all of those changes, but deducing this also deals with a few other problems in the language, like you can now do recursive lambdas, you can now do the curiously recurring template pattern without having to template your type on the derived type, and a few other bits and pieces. So I'd recommend going and reading the paper if you're interested in that. And with that, I'm going to head back to the slides. These are all of the features which I just showed. I'm not going to talk through all of these, but if you come back, then here is a little list of all the features which I just showed. Onwards to performance. So our team saw this Reddit thread. Dear MSVC backend team, why so silent? Why are you so silent and afraid to show your work? And the basic idea of this is that people want to see more detailed analysis of what the backend team is up to, what optimizations we've been working on, advances in code generation, that kind of stuff. So why don't we do it? Let's show you some code. Now here is a function with a loop, and inside this loop there is a condition. And note that this condition is not based on anything which is changing inside the loop. So this could have some performance impacts. If we have some branch prediction going on, then we're making this condition check every time. This could make our program run slower. So it would be better, generally speaking, if we could hoist this this condition outside the loop and write the code like this. And you generally wouldn't want to write the code like this in C++ because this makes it harder to maintain, it's harder to read. It would be better if the compiler could do this. So that's exactly what we do now. I'm going to show you some assembly. Don't worry too much if you can't read x64 assembly, but I will highlight the important parts. So here is before. The important thing to note here is that we have our test inside the loop. This is right underneath that label for the inner loop. And now in the after code, we hoist this out above the loop. So this is checked once before, and then we have done unswitching on the loop as an optimization. Let's see another one. Here is a bunch of chained min and max calls, which can generate some pretty fast code if you do it right. We used to generate a lot of instructions. Again, don't worry too much about what this is doing. Just note there's a lot of things going on here. Whereas now we generate this. So if you have lots of chains of min and maxes, we do a lot of analysis to try to make this a lot faster, generate much better code. Let's talk about vectorization. Here's a function which has a loop which is striding backwards. Notice that pointer minus minus. And it used to be that we would not do so well on vectorization if the loop is going backwards. But now this is the code which we used to generate, and this is the code which we generate now. And yes, it is now larger, but if you're familiar with how vectorization works, this is pretty much what you do. You generate all of these like pun-pickled instructions, and these will operate on a larger section of the data rather than just doing one element at a time. As a final one, here is a byte swap implementation. There is now a std byte swap function in C++23, but if you still have things like this which sit in your code, MSVC used to generate something like this, which is not great because x64 does have a byte swap instruction. So now we can work out that, oh, hey, this is just a byte swap, just written in C++. We can optimize this. So if you have byte swap functions and aren't using compiler intrinsics or the new C++23 version, then you should get some improvements there. And we will have a blog post, which we'll get out in the next few weeks to go through some of these again, if you're interested in reading more. Also on the back end, our ARM64 EC toolchain is production ready. So this is in addition to Visual Studio now running on ARM. We also have the ARM EC toolchain, which lets you mix ARM and 64 code, x64 code in the same process. So you can port your x64 apps to ARM incrementally without having to do it all in one big batch. All right, that's what we have on performance. So we're going to move on to all the other things, which I broadly put under this heading, feature of importance, because it rhymed, and I like rhymes. So productivity in the IDE. You saw earlier our inline hint feature, where you just hit Alt F1 and you can see the inline hints going. We have that refactor aware go-to definition, which you also saw, and then context aware autocomplete for enum types. And I'll show you that in a little bit. In terms of raw numbers, people like numbers. So here's some numbers. Our find all references. Again, this will very much depend on your workload. So don't take these as, oh, if I upgrade, I will definitely get these numbers. It does depend on the kind of code base and machines that you're using. But these are the kind of things which we are seeing in real benchmarks. So 3.5 times faster on find all references, 1.4 times faster on go to file, find in files 4.5 times. So a bunch of speed ups across the board. And then even more on opening the IDE, a little bit faster. On indexing, about 2.5 times faster. Colorization, when the IDE is warm, 6 times faster. Cold colorization, about 2 times faster. And solution loading, when the IDE is warm, about 1.8. So across a bunch of different scenarios, again, caveat on your workload, you might see some of these kinds of numbers of improvement. Specifically for Unreal, this is time to colorization for a file, time in seconds, and you can see it's gone way down over the last few versions. We've worked hard on specifically Unreal support. We do have some specific features coming for Unreal as well, and implemented recently. So we now have the ability to add an Unreal Engine class without leaving Visual Studio. There's a wizard which can do everything for you. Coming soon, we will have blueprint support for Unreal Engine. We have a little screenshot here. This is not going to be final UI. It's just to show you kind of how this support might look, but this is something which is going to be coming soon. On static analysis, we have added a bunch of new checkers for optionals, where there are now warnings for you're definitely going to unwrap an empty optional here, or you might unwrap an empty optional in certain cases, and you can treat these differently because that potentially unwrapping has a higher chance of getting false positives. And then we have some enum checks for when you're using enumerators bitwise. So you don't want to be testing these things with equals generally. You don't want to forget to set the value of your bitwise enumerators in the enum declaration, and you don't want to mix enum types when you're doing bitwise operations. So we now have some warnings for these. For CMake integration, you saw some of this already. It's been a first-class project system for a while now, and we keep on adding new things to it. So we want you to have that same familiar edit, build, debug, inner loop. You can target a multitude of platforms. You can use CMake presets.json now, store this in your CI, get the same configurations anywhere. And as you saw earlier, we now have some basic module support for Visual Studio Generator projects. You can always go take a .ms/CMake to find out more. For Linux specifically, last year we talked a bit about our WSL support. We have some new things like interactive SSH terminal for Linux, so that you can SSH into a remote machine directly from Visual Studio and deal with it there. And also CMake presets for Linux all set up for you. And you can go to VS Linux there to learn more. We've got a question that is the VS generator required for modules in general or just for consuming outside modules? It is required for building them as well. Like the build system has to work out all of the dependencies between the modules and all of that stuff. So yeah, you need to use the Visual Studio generator for that. For macOS, I had a few new things, such as remote debugging support, and that's both for x64 and the new M1s. Now, one thing which I particularly am very excited about is I'm a huge compiler explorer user. I love it. And there is now execution and static analysis support for MSVC on Compiler Explorer. So if you're used to compiling your code and running it on Clang and GCC, you can now do this from MSVC, and I'll show you in just a minute. And you can also check out our static analysis right from Compiler Explorer. On vcpkg, which we saw at the start, we're now hitting around over 1,900 open source libraries, which are available for installation for a bunch of different targets. And you can go to vcpkg.io there to both find out all of the features and to search for what different packages are available and what platforms they're available for. We did speak a lot last year on our advanced features like registries for making your own private library catalog, versions for choosing exactly specific versions of libraries, manifest files, which you saw earlier, and binary caching, so you don't have to rebuild these in CI all of the time. One new thing is artifacts, which is a way to pull down the build tools you need for building your code. Right now, we are focusing on embedded for this, but this will be rolling out to more scenarios as we work on it. On that subject of embedded, we have a few new things for embedded, this Linux and embedded workload, which you can use the vcpkg activation for toolchains for that vcpkg artifacts, which will automatically recognize that you've got a vcpkg artifacts file and activate that environment, get all your build tools, set up the toolchains. We also have some support for on-chip debugging with all your hardware breakpoints, some new views for RTOS objects and for embedded registers, and also a serial monitor for communicating over serial ports. Now I'm going to move on to a second demo where I'm going to show you some more developer ecosystem stuff. But first, I want to make a few more changes in my code base. So let's add something new here. Say, if you remember from the start, there was a cat in our game world. So maybe we want to add support for petting the cat. So we can add this to our parser. We can add a rule to recognize the pet string and to return a pet enumerator, which we can add in here. And then when we parse this, pet takes an object. You don't just pet, you pet something. So we're going to add this here. And then in our main, if we parse a command and it is pet, then we can do case here. And if we hit control space, then you'll see that this has filtered down to basically just our command types. So we can see pet is here. It's giving us both prefix with the enum name because it's scoped enum, and it's also giving us just the bare enum because I have a using enum declaration up here. So we can do that, and then we can say return do pet, which is a function which I wrote before this because I did not want to implement it live. And we can build this. While it's building, I'll show you the do pet is just checks if the object is Marshmallow, which is my cat's, well, one of my 3 cats' names, or cat, and that you're on the start level. And if so, then it will say pet Marshmallow, otherwise you cannot pet that. I have a question in chat saying, how do bitwise enums work? That's when you have an enum with enumerator values, which are powers of 2, and you use the enumerator values as flags. So you, for example, set like a specific bit for a specific enumerator value, and then you can have like several enumerator values set on one single enum object, and then you can test those using bitwise operations. You can set them using bitwise operations. It's not an annotation. There's a question, is that an annotation? It's not an annotation. It works out that you are using such that kind of enum by saying, oh, look, all of these are powers of 2. And, it can get a little bit fuzzy because if it's just 1 and 2, sure, those are powers of 2, but that doesn't mean that it's you're going to be using them as bitwise enums. But there's some logic in there to try and deduce that you're using them in a bitwise manner. Okay, so that succeeded. And if my Zoom controls go away, let's see if I say I've answered all of these questions, then hopefully my there we go, my Zoom thing went away, so I can actually click on this now. All right, let's run this, and we can see that we can now pet Marshmallow, and all should be good in the world. So this is just linking, and in a second, we should have our window up. It seems like it might be, oh, there we go. All right, here's our window. So we can say pet cat. You pet Marshmallow on his little head. He looks pleased. Lovely. And now we can say pet cat after we've, whoops, if we go down first, then we can pet cat, and it should say, yeah, you can't pet that because we went down and Marshmallow's not there anymore. Wonderful. Okay, so let's show some Git stuff. Now we've had this Git changes support for a while, but we've made some advances recently. One thing is we could go to a single change here and say stage just this line. This can be very useful if you've got a larger change set, but you only want to push some of these upstream. Maybe some of it is like debug changes, or you want to split up a larger change set into multiple commits. This can be very handy. Let's actually, before we commit this, let's create a new branch. We'll call it demo. And we'll take our changes with us. So now we're on a new branch. We can commit this. We'll just call it as expected. And if we commit this, I can show you if we come to our main branch, right click and compare with current branch. This is a new feature which lets us compare our two branches directly in Visual Studio without having to go to GitHub or whatever you're using. So if there are more changes in here, then I would see multiple files in this tree view. Shows me the name of the most recent commits and who did them. So this can be super handy just to see some changes between multiple branches. So that's our new Git features. I mentioned fuzzing earlier, so let's talk about fuzzing. So we do have a parser as part of this project. It is a pretty simple parser, but it is a parser nonetheless, and it is just taking a string from the user. So, this could be anything, right? And we have a bunch of commands which we should be testing. We should be testing for some bad inputs, but it's hard to test everything because this could be so long. It could have any contents in it. This is a really, really good target for fuzzing. So what I've done is set up a parser fuzzer, which just has this fuzzer entry and then links in our parser implementation. In order to link in libfuzzer, I just pass fsanitize equals fuzzer. And I also pass fsanitize address. You don't have to use address sanitizer while fuzzing, but it is recommended for finding as many bugs as you can. This is experimental, but you can use it for finding some bugs. So let me start running this, and I'll show you the code. This is just a single function, test one input, and it just passes some data and its size to parse command as a string. So this is going to run now. And here is our fuzzer running. Oh, and it looks like it just found a bug. Yep. It found access violation reading address 0, which is null. So if I go back and look at this, this is kind of a trace of the kinds of things which libfuzzer did in order to find this bug. And sometimes it actually finds little strings which change the behavior, like here. It found the string east and recognized that hit a new branch of the code. So it's not just blindly trying different strings. It is a little bit smarter than that. And it found a bug here, so we can go to where our code is. And yeah, it found a bug on this very suspicious looking line of code. I don't know who wrote this. They're trying to construct a string from a null pointer and 1. Seems very silly. But you can see it found it on the right line, and it also tells us here that H was the input which it used. So that all seems to work. Great. Now I did mention Compiler Explorer. So if you're not familiar with Compiler Explorer, you can come here and try GCC, Clang, MSVC for a variety of different targets. And the basic idea is that code goes here. So you can say int main, make an uninitialized variable, and the assembly is going to go here, and any output goes here. And now this is a static analysis window, which I can open with add tool static analysis, and it immediately says that variable I is uninitialized, which is handy. And if I have output execute the code on, then it will actually execute the code as well. So if I, for example, come here and include iostream and do cout hello, then this should recompile and we should see hello over here in just a second. Taking a few seconds. There we go. Hello. Success. So you can go and have a play around with this. Now, we always try to show you something which is coming up, which isn't quite ready yet, but to give you an early glimpse at some new things we're working on. So I'm going to show you that now. I'm going to show you what's coming up for diagnostics, both in the compiler and in the IDE. So let's make some code. Say we've got cat. Oops. Say we've got dog. Struct. Helps if I can type. And if you've got a cat and a dog, then of course you're going to have a pet function. So what happens if we have a main function and we call pet with something which is neither a cat nor a dog? And we should get a compiler error, right? And we do. Now, again, this is not ready to play around with yet. This is going to be coming in some future versions of Visual Studio, and we're giving you an early glimpse. If I double click on this opens up a little window here. This is actually generating serif, which is a file format for diagnostics, for structured diagnostics. So this is generating a serif file, which is then being picked up by the IDE, and this serif Explorer extension is visualizing it. So this gives us some more information about our diagnostic. It says that no overloaded function could convert all the argument types, and it gives you some more information. It gives you all of the possible overloads. So if I double click on that, it highlights dog, highlights cat, if I click on that, and I can expand these out to kind of navigate our diagnostics. So cannot convert argument 1 from int to cat. No constructor could take the source type, or constructor overload resolution was ambiguous. Okay, this is kind of cool. What if we have something a bit more complex? Say we have a struct which we'll call rabbit. And maybe this says constexpr static bool is petable, is true. And that means, hey, we should generate some default implementation of pet for this. And then maybe we have, I'm just going to close this for a sec. Maybe we have a struct called lizard, which we don't want the default behavior, so we have a specific pet function for lizard. Now, how would we write a concept which would recognize these? We could do something like this, concept petable. Either it has a member pet, or it is default petable t. And then we can define concepts for those. So concept has member pet is going to requires given some t called t that you can call t.pet. And then our concept is default petable is just going to be t is petable. All right. So now we could write a function template which accepts any petable t and lets us call pet on it. Now what happens if we compile this? Oh, this has not opened up the serif window for some reason. Anyway, this is what the built-in, if you don't have the serif extension installed, this is what the built-in view is going to look like, just so that you have a decent experience regardless of whether you have the extension installed or not. And it looks pretty much the same as we had earlier. We have our dog and our cat overloads, and they say the same thing. Cannot convert argument, no constructor. But then we also have this pet one, and it says the associated constraints are not satisfied. That's used to be pretty much all you would get out of the compiler, but now we've improved things a lot. So it now says the concept petable int evaluated to false. Okay, why? Well, because the concept has member int evaluated to false and is default petable evaluated to false. Okay, why? Because this expression is invalid. And why did this one fail? Well, because you tried to do int : is petable, and that's not valid. So you can see that we have much better diagnostics, especially for concepts, and we now let you navigate them in quite a nice, understandable way. You just see all the overloads, potential overloads, and then you can dig deeper to find out what went wrong if you want to. One other thing for the serif extension is key events. So here's another little project which I already had ready. So this has some issues with uninitialized variables. And if I build and click on this using uninitialized memory, this will open up the serif Explorer and tell me, hey, what were the reasoning behind coming up with this? Why is this uninitialized? Well, because these are the steps which the analysis went through to discover this use is potentially uninitialized. So you can follow the reasoning of the static analyzer and see it directly in your code.
All right, so I showed you the improved Git support in Visual Studio, our constantly improving asan support, including the new added libfuzzer. And when it comes to diagnostics, you've seen the new integration for MSVC and Compiler Explorer, and an early peek at our experimental diagnostics work. So I want to talk a bit about this experimental work. You can see some of the results of the work we already started in the latest preview, and you can read all about this work if you follow that link over there. So what is this work? So this started with a size paper now that is publicly available and linked in the post we just published that stated that compiler error messages are a tiny bit out of control. And that we need better error messages for humans to read. For us to deliver on that vision, we kind of had to take a step back in MSVC and do more than just deliver human readable output text. What we need as consumers of this error messages is to have a structured output first that allows us to visualize diagnostics rather than just read them in the output. I hope you've seen the value of this approach in Size Demo, and this is just the start. Again, follow the link to learn more about our ongoing work in the compiler to improve concepts diagnostics, the infrastructure work to generate the structure output by using Sarif as a format, and the visualizations we're building for these types of diagnostics. There's no coincidence that our MSVC static analysis already uses Sarif support, and it's already benefiting from all of these visualizations improvements as well, with even more checks coming soon that are going to use this rich visualization in the future. There's built-in support in Visual Studio for diagnostics visualizations, as you saw, but we're also we'll also be experimenting more aggressively through the Visual Studio extension that you can download from the marketplace called Sarif Explorer. We have an enthusiastic team working on the Sarif extension, and they need your input. I'm really excited about the potential of this work, so let us know what you think in the comments on Twitter, in DevCom. We think we're onto something here, but are we? We're definitely listening. And speaking of early peek at our work, in addition to GitHub hot spaces and that has GA'd earlier this year, we announced Microsoft DevBox. And it's an effort to make peace between developers and IT department when it comes to managing VMs in the cloud, which is a growing need in this remote first environment. So to learn more, check out the recording from Michael's session yesterday on reproducible developer environments, which covered both code spaces and DevBox, and follow the links as well below. As we're getting close to wrapping this up, I want to add that all of this ongoing work of improving Visual Studio, it's only possible if you share your voice, whether you're reporting a bug or just sharing suggestions about how Visual Studio can make your life better. We're listening in the developer community portal and making progress on the areas of impact for your experience. So while we haven't got to all of the things in the list here to show them to you today, I did want to share the list to encourage you to head over to developer community in the link below and share your suggestions and complaints. We're listening, and as I was saying earlier, our mission says that we're trying to make every C++ developer's life better. So on behalf of the whole C++ team at Microsoft, Cybrand and I want to thank you for tuning in and wish you happy coding.